Hi, in this video we are going to have an overview of ARM instruction set. ARM instruction set is a set of 32-bit instructions. ARM version 4T and later processors defined a 16-bit instruction set called thumb instruction set to reduce the code density. But they come at a price of performance. Later thumb 2 instruction, which is a mixture of 32-bit and 16-bit instructions, is introduced to have good performance and better code density. We are going to discuss only ARM instruction set here. So let us see how they are classified. They are classified under 5 main groups. First is branch and control instructions. They are used to have loops, conditional structures, make following instruction conditional without branching. They are used to change the processor state between ARM and thumb. Then we have some data processing instructions. These instructions are used to perform addition, subtraction, multiplication, or to do bitwise logic operations like OR and AND. We can give immediate data in these instructions. Then we have register, load and store instructions. These instructions load or store the value of single register from or to memory. Then we have multiple register, load and store instructions. These instructions load or store any subset of the general purpose registers from or to memory. Then we have status register access instructions, where we can access the CPSR flag bits. Then we have some co-processor instructions which are used to give additional features in ARM architecture. Let us see how a typical 32-bit ARM instruction look like. Here let us assume that this first row represents an add instruction. Let me tell you one thing, that first 4 bits of every ARM instruction set represent condition. So in add instruction, the first 4 bit is for condition, then opcode add comes, then the first operand comes, then the register that the destination register where the value of addition is going to be stored comes, then operand 2 comes. Various instructions is going to be packed in a 32-bit form according to their requirements. These are some instructions in ARM instruction set. In ARM instruction set we have some suffixes. We have 16 suffixes which work according to various CPSR bits. If we don't add any suffix, the instruction run without checking the CPSR bits. So let us simulate some of the instructions in keil. Here we are going to begin with data processing instruction. We first have add instruction, which adds 9 to the value of previous value of R1, which was 0. Then R1 becomes 9. Then we have subtracting the value of R1 with 6 and storing the value in R2, which is 3. Then we are ending the value of R1 and R2 and storing it in R3. And we are moving the data of R2 to R4. Then we have branch and control instruction. We are having a dummy loop here, which subtracts the value of R4 in each iteration. We are having a condition here. If R5 becomes 3, then it will jump out of loop. We are using BGE here. B is the main instruction and GE is the suffix, which means greater or equal to. Let us see how it goes. After the third iteration, R5 has become R3 and it should come out of the loop. Yes, it has come out of the loop. Then we have some register, load and store instruction. Here R6 is having value 0x4. It is acting as a base register. After LDR R1 comma R6 in parenthesis, the value of the address pointing by R6 is stored in R1, which you can see a 32-bit value is stored in R1. Then we have multiple register, load and store instruction, LDM, which is used to store value in group of register. R6 is acting as base register here. And after this we have we can see that R1 to R5 are loaded with values um, which is started by R6. You can verify it from the memory window. All red colors are seen are indicating that these values are stored in registers. Then we can access the CPSR bits by using instruction MRS and MSR. We are having MRS instruction here. It is used to store CPSR value to register. After this instruction, the CPSR value is copied to R1, which you can verify here. Okay, this all I had to say. You can try as many instructions as you like. Thank you for watching.